All right. So everything about relativity comes down to this idea. The speed of light is equal to a constant. No matter where you are or what you're doing, if there's light, you will always measure it to be going c, or basically 3 times 10 to the 8th meters per second, presuming it's in a vacuum. The math showed this. Einstein was able to show it. What Einstein was clever enough to do was to actually believe this to be true, and then be able to say, here are the consequences of this statement. He didn't come up with the idea that the speed of light had to be a constant. He just said, let's see what happens if it is. So let's presume for a second you're in a box, all right? A very large box, all right? But your box has no windows, so it's a pretty boring box. Right? So to just amuse yourself, you pull out your pocket laser and you shoot a laser beam up, a really quick pulse, and the laser beam goes up to the top where it hits this mirror that you have conveniently put there, and it then bounces back. You want to have a way of measuring the time of return. All you've got is the fact that it's light, so you're thinking, hey, velocity is distance over time. And the reason we can use this equation instead of one of our kinematics equations is because speed of light, the acceleration is 0. So this becomes c because this is a light pulse that's moving. Equals the distance of travel over the time in the box that you're measuring inside the box. The distance is twice however high it is going up. So we're going to call that distance d. So it goes up d, down d, so this would be goes 2d over t in the box that you're measuring. So the time you measure as you stand there in the box is 2d over the speed of light. Unless this is a very large distance, this time is going to be a very, very small number, but it's still a measurable number with atomic clocks and other such things, or using some type of infrared beam that the laser is breaking. Now, this is just a simple application of velocity is distance over time. It's no different than if you had thrown a ball up. Well, can't use a ball because of gravity, but assuming you were traveling at a constant velocity, there's nothing unique there. But what I didn't mention to you is this. Your box is actually a train, and your train is actually moving to the right at, some constant velocity. Turns out that the fact that it's constant becomes important. Now, here's the first question. Does this fact that I just told you, the fact that it's a train moving at constant velocity and not just a box, does that change any of this information at all? Well, you're still going a distance, same speed because it's the same light. That doesn't change at all, as long as you're going at a constant velocity. In fact, if this is a perfectly smooth train, you won't even know you're going that fast. Think about it when you fly in an airplane. When you fly in an airplane, unless there's turbulence, or you're landing, or you're taking off, you don't even really recognize that you're traveling 400 or so miles per hour. That's just a statement of inertia. Objects in motion stay in motion, everything's moving around you, and you don't have anything to measure from. So the fact that it left out the fact that it's a train at a constant velocity is no big deal.